Now we take the application of the previous theorems by taking an example. Let x1, x2 up to xn be the random sample from the normal distribution that has the probability density function, that is the usual normal probability density function. Investigate for the sufficiency and the completeness for the theta. So how we proceed that? First of all, we can write the normal distribution in the form of exponential as by expanding its square, that is 1 over 2 pi sigma square under root, that is exponential, minus just opening the square, x square plus theta square minus 2x theta divide by, that is 2 sigma square. So further we can write it as in term of exponential family, exponential, that is first of all this part we can write it as 2 से cancel हो जाएगा, तो हमारे पास जो बाकी की चीज बचेगी we can write it as theta sigma square into x minus, next we can write it this term, that is minus x square over 2 sigma square. Next we can write this term, that is minus, इसको जब हम exponential के अंदर लेके जाएंगे तो इसका log ले लेंगे, so that is basically log 2 pi sigma square and then minus theta square over 2 sigma square. And here sigma square is any fixed positive number. So this is a regular exponential class with, that is p of theta, here that is equal to theta over sigma square, p of x, that is simple x, h of x, that is actually minus x square over 2 sigma square minus log under root 2 pi sigma square, and q of theta, that is actually equal to minus theta square over 2 sigma square. So according to y1, now we are using the theorems which we just studied in the previous module, that is y1, that is actually the sum of k of xi, here actually that is x1 plus x2 plus up to so on xn, and we can write it as nx bar is a complete sufficient statistic for theta of normal distribution for every fixed value of sigma square. And since expected value of y1, that is actually the sum, this one, so that is basically n theta, then the function of y1 which is represented by phi of y1, that will be actually y1 over n, which is actually the x bar, and is the only function of y1, which is unbiased estimator of theta and being a function of sufficient statistic y1, it has a minimum variance. Thus, x bar is the unique minimum variance unbiased estimator of theta and a complete statistic theta. Now you can see that by writing the any probability density function in the given form, we can also using this theorem by using, let's say, y1 that is equal to some k of xi, that is some function of x basically, and then we can easily show that it is a sufficient and complete for the theta.